On December 8th, 2020, FireEye, one of the most respected cybersecurity firms in the world, announced that they were the victim of a nation-state attack and that their red team's toolkits, the primary tools used to perform their ethical hacking, were compromised. 5 days later, they reported finding evidence that the attackers get in through a backdoor in SolarWinds Orion software. SolarWinds is a vendor that they use to monitor their IT systems across the company. In the following weeks and months, SolarWinds confirmed the breach, and hundreds of similar victims came up, ranging from tech giants to critical infrastructures to governments, all breached because this vendor that they used and trusted was compromised upstream. Roughly 4 months later, on April 15th, 2021, a company called CodeCov reported that it was breached. And CodeCov's tools are tools that integrate into the customer's software pipelines to help developers assess how much of their code is actually exercised by their automated tests. The attackers managed to compromise the CodeCov components that run inside the build system itself, granting the attackers access to the build systems of hundreds of customers of CodeCov and allowing them to steal precious credentials, which they've done, and potentially modified shipped code from those customers' pipelines, which fortunately it appears they haven't actually done. Adding fuel to the fire, late last year, on December 10th, 2021, an extremely critical vulnerability was found in a massively popular open source library called Log4j. Log4j is used to log system and user actions in Java application and is extremely prevalent. It's used by practically any company with a bit of tech mileage and using Java. The vulnerability was dubbed Log4Shell, and it's a remote command execution vulnerability. And the easy exploit made it trivial for attackers to run commands on victims' servers. And this combination of the widespread usage of Log4j and the ease of exploitation sent much of the security industry into this spin, a lot of sleepless nights, trying to quickly find and patch all the places that this library was used. These three anecdotes, and many like them, are all examples of software supply chain security issues. They're each quite different from one another, but they share the fact that the organization was put at risk because of a piece of software that they were consuming as opposed to something that they wrote. It was an upstream software component that the company was using, be it open source or commercial, that had a security problem or was breached, and therefore the company itself is now at risk.
Hi, you're listening to The Secure Developer. It's part of the DevSecOn community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk's developer security platform helps developers build secure applications without slowing down, fixing vulnerabilities in code, open source, containers, and infrastructure as code. To learn more, visit snyk.io/TSD. That's SNYK.io/TSD.
The growing number and impact of software supply chain attacks and vulnerabilities has put it firmly in the headlines. From a US government executive order through a fast-growing open source foundation to a lot of open source and standards activities, software supply chain security is a hot topic and it's moving fast. It's also very confusing. The breadth of the space, the urgency to do something about it, and the rapidly changing landscape combine very poorly, and they make it very hard for you to feel like you have a handle on the topic and know what you need to do about it, which is precisely where this mini-series comes in. And the next few episodes will combine our analysis of this space of supply chain security with a series of interviews that we've had a chance to do with other supply chain security experts. And we're going to try and create a clearer picture of what this topic involves and what's the sort of the state of the land, and try to help you understand what is it that you should be doing about it. In this first episode, we'll focus on defining the problem. We'll try to break up the key pillars of supply chain security and talk about which ones you should care about the most and why. The second episode will get more specific, covering some key terms you should know about and key players you should track, as well as talk about some of the most prominent or promising projects in the space so you can deep dive. In the third episode, we'll give examples from practitioners that are actually implementing supply chain security in their own organizations so that you can learn and choose which of these practices you want to adopt. And we'll talk a bit about maturity levels and, how do you get started versus how do you continue. And then lastly, in the fourth episode, we'll cast our eyes forward and talk about industry motions, what can and is being done to help the ecosystem deal with this problem, and what key changes might you expect to come down the road.
To be able to address any challenge, we must first understand the scope of what we're trying to solve. And that's why it's very important to define what software supply chain security is. What should people think about when someone talks about software supply chain security? What's the scope that people are covering? Now, Guy Podjarny, the founder of Snyk, and Eric Brewer, Google Fellow, VP, and longtime faculty at UC Berkeley, will take us through what software supply chain is really all about.
We say supply chain security for brevity, and most people do, but really we're talking about software supply chain security and ignoring maybe some other topics of supply chain security, literally of how has someone physically brought in some piece of equipment to your office or something like that. Within software supply chain security, there's another sort of subdivision, which is commercial and open source, which we'll get into. But at a high level, software supply chain security is how secure is your use of the software that you are consuming versus what you are producing and the journeys that they undergo. And so at its very meta interpretation, it includes any commercial and open source software that you are consuming, knowing what you're using, knowing what are the known security flaws in it, whether it's vulnerabilities or it's more sort of incident style compromises and responses to them, and knowing the journey that they have kind of undergone. So knowing whether you're consuming what you actually think that you're consuming, were they sort of built securely, and are you yourself, like, is nobody tampering with this piece of software that you're consuming as you go through it?
Well, like any supply chain, there's many things that go into something you use, like your car. Like, why do you trust the car is safe to drive in at very high speeds? And it's not because you know everything about it. It's because you kind of trust indirectly through a chain of vendors who actually then review each other and build a layer of trust. That's more of a social process. For software, we need the same kind of thing, especially in open source, where we have a huge number of dependencies and we're pulling from all kinds of suppliers, where honestly, we don't typically know much about our supply chain today. And that has become a critical threat to the nation and the world.
The scope is huge when you look at supply chain security, right? And it's really the way that you build, ingest, and deploy software as an entity. And really a supply chain really does come or start right down at the initial dependency level, all of your dependencies for the application, through all of the components that you bring into an enterprise, whether that's within routers or databases or the applications that you then build. And then you need to continue that journey all the way through to how you distribute that software to your clients. And it's a true chain, so that multiple different enterprises within that chain need to look at their supply chain, and you need to be aware of what that looks like as well. Right from effectively who's building the chipsets in your servers, right through to who's putting the firmware onto them, applications on top of those, through to you consuming that as an enterprise and then delivering an application to your customer. So it's a really broad problem that obviously multiple different industries also tackle. And the difficulty with a supply chain and supply chain security is it really is as secure as the weakest link. So you really do need to get a good grip on where you're getting your software ingredients from as you're looking at that problem.
It's a multi-armed octopus, or I'm not sure what the right metaphor here is. But the reality, I think, for most, actually probably for everywhere at this point, is that the vast majority of the software that you actually ship comes from somewhere else, right? The percentage of the code that's written by developers inside of your environment and under the remit of your specific organization is maybe 10%, maybe 15% of what it is that you actually ship, whether you're in cloud or whether you're producing a mobile device or whether you're like all of these. It's a conglomerate of third-party services, third-party software, could be licensed software through a negotiated license, could be open source software. The vast majority is probably open source at this point, which is super interesting because they don't even know that you're using it. So they don't know that they're part of your supply chain.
On the Secure Developer, we speak to many experts, and they all agree that software supply chain is the aggregation of all of the complete journeys of every piece of software that you consume from inception. And that includes all the systems they travel through, all the people that touch them along the way. When we spoke to Jim Zemlin, Executive Director at the Linux Foundation, he took us through this journey of all the pieces of software.
The most important thing to understand before you start talking about software supply chain security for someone who's not familiar with the space is to understand how code flows around the world. It sort of starts with a developer who works in a version control system, writing software, right? And a lot of people think writing software is just sort of math and if this, then that type of thing. But there's a real art to software and a real elegance. And you have these thousands and thousands of creators out there in the open source community that write software. And so they do a lot of that work on GitHub, but they also do it in places like GitLab or other version control systems that are used every day by millions of developers all over the world. Once they write that code, they package it up. Well, they build the software. They use a build system to compile the software so it's like actually usable and can run. And then they package that up, combine it with other packages. Today, there are package managers, little software factories that kind of combine all this stuff together. And then that's integrated together and off to a IoT device, an operating system, a cloud service, whatever it is. But when I think of the supply chain, I think of starting with a developer writing code, compilation, package management, all the way to an end user, right? And most people, I think, when they think of the software supply chain, they think somebody writes some software and all of a sudden, magically, I'm using it on my Android device or my Chromebook or as a cloud service with the website I happen to be logging into or whatever it is. And there's a lot of different points in between that. And that's how I like to think about supply chain security in terms of how code flows. The second thing you start thinking about is at every point when software is handed off down that production frame, like that as it flows from the what we call upstream in open source, which is, the developers working on it in a repo or in a version control system, to build system, to a package manager and so forth. At each point in that process, crazy things can happen. As you know, your company specializes in understanding all of those places. You can have a bug in software. This is sort of the most common way that vulnerabilities happen. And it's not some malicious plan. It's just a developer is writing a lot of software and they write it in a way that there's a mistake that might have happened, or they may not have fully understood security aspects of software development. And we're really like, hey, I got to get this next feature written and ship this code. That goes out. And, just that unintentional bug can produce a real security problem. But that's only the beginning of how code flows, right? So I made that problem there. You can then, when you're combining that software with other packages, bring in a package unintentionally that may have malicious code in that. People can type squat names of common packages that maybe a developer typed in the dependency name wrong for a package they wanted to use. When they combine it all together into some code, and there's a malicious actor out there like kind of squatting on a JavaScript package that all of a sudden produces a vulnerability. You can inject vulnerabilities at different points in that supply chain. There's just a ton of different attack vectors as you go down throughout the supply chain. And that's why everybody talks about the supply chain in that way. Bypass code review, compromise source control systems. You can compromise at the build pass form. You can bypass CI/CD. You can use a bad dependency, as I mentioned. You can use a bad compromised package repo and so on and so forth.
the vast majority of attention and practical use of software supply chain security topics is around open source usage. And the reason for that is if a vendor has written some piece of software and they have a vulnerability inside of it, then it really is a very localized problem. And it comes back to the typical trust that we put in our vendors, which is, hey, just kind of write secure software and be on the hook of being compromised. However, if a vendor is using an open source component, the consumer of that might actually know elements or have an opinion about how secure or insecure that component is. And all they really needed the vendor to sort of inform them about the component that is inside.
A lot of what you're hearing around open source security isn't really new. We've been using open source, we've been using third-party libraries and commercial products for a long time now. We've had things in pipelines for decades now as well. So why is there all of a sudden a greater concern? Has there been something that really sparked the attackers to target supply chains more, or something that triggered within organizations, perhaps a regulatory or compliance-related need? Guy Poe and Nicole Perlroth, author of the New York Times bestselling book, This Is How They Tell Me the World Ends, have some really interesting insights on this topic.
We need to understand how we got here. I think there's sort of the slow burner and the fast kind of flash that combine together. The slow burner is that over the many years, the amount of proprietary software versus sort of open source software or consumed software that we have in our applications has greatly changed. It has gone from some 20, 30 years ago. If you were to sort of buy a software product, the vast majority of what was inside of that was written by that vendor. And the supply chains were basically less complicated. While today, if you buy a piece of software, it's most likely that 90% of the software that is inside is not actually written by that vendor, but they themselves consume that out of open source components or their own upstream vendors. This supply chain, just like in the physical world, allows us to produce more, to be more productive. It's a specialization, but it means that the risk of any one of these components being weak has increased. And it's very similar to maybe what we're seeing now with sort of how the pandemic has affected supply chains, physical supply chains in the world. There's this chain of dependencies that over the years we have optimized to sort of make the most of and be most productive in, because every part of the ecosystem knows how to produce their piece in sort of the cheapest and best way. But it also makes it fragile. And once one of these pieces gets out of balance, it throws the whole system into a loop. One trend that has happened is really software is more dependent on supply chains. And so software supply chains are just more of a focus of attention. And that has happened incrementally over the years. And then the flash event that has happened to doing it is just this series of breaches. And specifically SolarWinds, I think, was a big eye opener for people. Nicole Perlroth on the interview here has kind of called it the watershed moment, has equated it to maybe the discovery of the Stuxnet worm that really shone a light to the world around offensive cyber from nation states and the fact that is a thing. And so I think what SolarWinds has done, especially because of the high profile targets that it had and the fact that it was presumably had the nation state behind it, it opened people's eyes to the problem that occurs. And we know for a fact that it's not new. It's not that these attacks on supply chains are new, but once you have something that has this type of high profile, it triggers things into action.
This attack really exposed our blind spot because they staged it at servers inside the United States where the NSA can't look. It was only discovered because Mandiant or FireEye discovered that they had been breached, and out of the goodness of their own hearts, disclosed that breach. It didn't touch PII, personally identifiable information, which would have triggered state data breach notification laws. So they raised the red flag, and thank God that they did. And then in rewinding the tape, discovered, okay, this started with the update that we did from SolarWinds, and we're able to flag that for SolarWinds and for everyone else. But otherwise, we might not have ever known about this breach. And they were inside our systems, I believe, for as long as 9 months before anyone knew about it. But the final thing I'll say about SolarWinds is what was stunning to me as a reporter was calling up all of these companies listed and government agencies listed on SolarWinds' website as customers and trying to confirm that they had been impacted or were at least in the process of trying to forensically understand whether they had been impacted. And half of them didn't even know that they had been using SolarWinds.
Now, the SolarWinds attack, of course, in 2020 really got the world's attention. Everyone was thinking about software supply chain from that day, and we were grappling with the challenges of managing third-party vendors and the risks associated with them. Of course, after that, in 2021, we saw a further breach, the CodeCov breach, and we had the pleasure of having Jared Engelberg, who is the CEO of CodeCov, and Eli Hooten, who is the CTO, and they shared with us some of the insights on that very breach.
Yeah. So what the attacker did essentially was enumerated the environment where the CI was running, basically running an env command, right, to see environment variables printed. The issue that arises is that in some CI pipelines, these environment variables may represent secrets or credentials that access other parts of a company's infrastructure, right? Perhaps maybe for example, there is an environment variable that's a token to access AWS or some kind of infrastructure. Maybe there's a Google Cloud Platform service account credential, right? Or something in there that can then be extracted from the environment and used in a follow-on attack specifically targeted at that company, right? So the env was taken and it was piped to just a third-party server. The attacker could then review later at their leisure. And so how that impacted customers was depending on the configuration of their CI, what they had in their environment, how things were set up, they could have leaked credentials to this attacker. Of course, if you're an open source library and you're used to your CI being totally open and everything being visible, you may not have anything of consequence in there. There might not really be any real reason to worry about it. If you're in a closed source case or you're potentially like putting a lot of secrets in your CI or your CI process is doing a lot of work across your infrastructure or your stack, there could potentially be quite a few sensitive secrets or environment variables there that would be concerning if leaked.
So this all sounds like the perfect storm. As a society, we've really changed how we're building our applications. And I think there's a cultural piece here whereby many years ago, when I was building software, if I wanted to introduce something back into my pipeline or an application like a third-party library, I would have to stop and think about it much, much more back then because it was a far rarer, less common thing to do compared to today when a developer will happily add a new library. And just because it performs the piece of functionality that they need, it's a much more well-trodden path today compared to before. And software obviously is relying upon open source much, much more these days than ever before, as Jim Zemlin shared. Society is relying on software.
In terms of ranking it from a cybersecurity perspective, it's pretty significant. In terms of just security in general or like national security and so forth, it's pretty significantly high, but in context of the conflict in Ukraine or other security issues around the world, it's adjacent in certainly seen physical conflicts in places like Ukraine also have a cyber component to it. I think a lot of people, when they think about cybersecurity risk, they think of it as non-impactful in a physical sense. And that's likely a somewhat naive assumption in that certainly if you're in an active war zone, this is like your top most frightening and horrifying situation. But if you're the victim of a cyber attack that cuts off fuel and electricity and communications and critical infrastructure that you rely on, let's say in a wintertime environment, that's also can be immediately physically threatening to your security as well. And as society has come to rely so much on software to manage critical infrastructure, again, energy distribution, transportation services, telecommunications services, medical devices, and so forth, cybersecurity and physical security are starting to converge. Why is it something? And so that's why, as of late, it's critically important for us to collectively secure from a cyber perspective, both software and the digital components that it runs on.
So we spoke about how visibility into open source libraries is a big problem, particularly when looking at something like Log4Shell. When that happens, a lot of organizations would probably question how much visibility they actually do have over their current estates, and understanding whether you actually know everything that you're seeing or whether there's some truly hidden bits under the covers. Brian Benioff, who is the general manager of the Open Source Security Foundation, shares his views on open source software and how this has changed over the years.
Well, I think open source software in particular, but you could say this about the whole of the software industry, came about at a time when it was small enough and the internet was small enough that everybody had a reasonable shot of at least getting to know software by getting to know the people behind it and getting to understand how teams work and all that kind of stuff. So we operate in a very high trust environment, and we just don't have that environment anymore. So some people might argue we never did, but the cost now of blindly trusting things you download off the internet or things you find in the GitHub repo or others to be truthful to the label on the packaging of what it is, that trust is under a lot of threat right now. We also tended to default trust that software developers, open source developers were taking certain proactive measures, that they would respond quickly when somebody found a security hole in their work or whatever. And that's not always the case. There are a lot of folks who aren't as diligent about fixing things, or where there's code that's been used that hasn't been updated in a while, and maybe the original developer has moved on to other things. Right. This is something that now we're just finding so many more places where that kind of default trust is being taken advantage of, whether in things like typo squatting in package environments or dependencies that aren't getting updated as frequently as they could be or should be, or other just kinds of behaviors in terms of how the software gets built. I mean, there's so many single developer packages out there and places where something like Kubernetes pulls in thousands of underlying dependencies where we can't scale based on the social tools that we had before.
The increased adoption of open source in our applications adds complexity to our software supply chain security. However, open source is still just one piece of the overall software supply chain picture. As Jim Zemlin explains, there's a lot more to software supply chain security than first meets the eye.
The second thing that happened is you now have a lot more critical points in that software supply chain with these package managers that have not matured as quickly as people who are trying to engage in cyber attacks have. Cryptographic signing for a lot of these package managers just really wasn't a thing, and in some cases still isn't a thing for a long time. And they really don't have fundamental security in those components as well. So now we're not just looking at what are the most critical open source projects? We're looking at, how do we shore up the distribution mechanisms and the CI/CD infrastructure and the version control systems? This thing gets a lot more complicated, a lot more quickly.
Supply chain security is not only complex because of the various components that are part of it, but also because of the scalability of the supply chain attacks, as Eric Brewer shared.
The important shift for supply chain security is that an attacker can take one of those vulnerabilities and turn it essentially into a repeatable attack machine, where by exploiting a vulnerability in the supply chain, all the groups that use that supplied software or those tools now have their things in jeopardy. And so a good supply chain attack can get 20,000 victims, right, with 20,000 sets of credentials to do further attacks. And so there's a great widening of power through this kind of attack, which is why we're going to see more of it.
There's so many different definitions out there that what I tend to do is I go back to my government roots, and I went back to NIST because I love their definitions of things. And really, I took what they had defined as supply chain security and distilled it into the elevator pitch version. So here it is. Processes that protect and secure the efficient integration of suppliers to allow commodities to be produced and distributed as planned. I think that, it's a lot of big words and it's a bit of a word salad, but if you actually look at it and digest it, to me, that's exactly what supply chain security is. If you don't have policies in place, it's not going to be efficient. If it's not efficient, you're not going to be able to integrate anything, because if there's inefficiencies, people don't want anything to do with that process. So if you don't have any efficiencies, you don't have any suppliers, you have no supply chain. It falls apart very quickly. And also, I think that the important word there is to allow commodities to be produced and distributed as planned. There has to be a plan in place. So, and I know these sound all very matter of fact and common sense, but that sentence, that elevator pitch, probably took me maybe an hour or two of just actually thinking and drawing it out and writing it out and having a clear understanding. I don't know if you've ever read any of Richard Feynman's books, the physicist, but he had this whole thing about where you can choose a topic and you can study it. And the first step is explain the topic to a child. So I wanted to try and explain supply chain security to my mum, who's not a child, obviously, but she's not in security. And I told her this. I said, do you understand what I'm talking about here? And she's like, yeah, I do actually. Yeah.
As Lena Smart, CISO of MongoDB, said, there are many definitions of software supply chain, and we've had the benefit of hearing some great ones on this podcast. We do hope that after this episode, similar to what Lena did for her mum, we were able to unravel what a software supply chain is for you, with an overview of its core components and why we need to pay attention to it. In the next episode, we'll be talking about some of the key terms that you need to know and some prominent players and projects in this space worth knowing about.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at @DevSecCon. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.